In addition to surface tension, hydrogen bonding, and van der Waals forces, there are also bizarre quantum effects at the atomic scale. Normally, we don't see quantum forces at work in everyday life, but quantum forces are everywhere. For example, by rights, since atoms are largely empty, we should be able to walk through walls between the nucleus at the center of the atom and the electron shells. There's only a vacuum. If the atom were the size of a football stadium, then the stadium would be empty, since the nucleus would be roughly the size of a grain of sand. We sometimes amaze our students with simple demonstration. We take a Geiger counter, place it in front of a student, and put a harmless radioactive pellet in back. The student is startled that some particles pass right through his body and trigger the Geiger counter, as if he is largely empty, which he is. But if we are largely empty, then why can't we walk through walls? In the movie Ghost, Patrick Swayze's character is killed by a rival and turns into a ghost. He is frustrated every time he tries to touch his former fiancée, played by Demi Moore. His hands pass through ordinary matter. He finds that he has no material substance and simply flows through solid objects. In one scene, he sticks his head into a moving subway car. The train races by his head, sticking inside, yet he doesn't feel a thing. The movie does not explain why gravity does not pull him through the floor, so he falls to the center of the earth. Ghosts, apparently, can pass through anything except floors. So why can't we pass through solid objects like ghosts? The answer resides in a curious quantum phenomenon. The Pauli exclusion principle states that no two electrons can exist in the same quantum state. Hence why two nearly identical electrons get too close, they repel each other. This is the reason objects appear to be solid, which is an illusion. The reality is, matter is basically empty. When we sit in a chair, we think we are touching it. Actually, we are hovering above the chair, floating less than a nanometer above it, propelled by the chair's electrical and quantum forces. This means that whenever we quote-unquote touch something, we are not making direct contact at all, but we are separated by these tiny atomic forces. This also means that if we could somehow neutralize the exclusion principle, then we might be able to pass through walls. However, no one knows how to do this. Not only does the quantum theory keep atoms from crashing through one another, it also binds them together into molecules. Imagine for the moment that an atom is like a tiny solar system with planets revolving around a sun. Now, if two such solar systems collided, then the planets would either crash into one another or fly out in all directions, causing the solar system to collapse. Solar systems are never stable when they collide with another solar system. By the rights, atoms should collapse when they bump into one another. In reality, when two atoms get very close, they either bounce off each other or they combine to form a stable molecule. The reason atoms can form stable molecules is because electrons can be shared between two atoms. Normally, the idea of an electron being shared between two atoms is preposterous. It is impossible if the electron obeyed the common sense laws of Newton. But because of the Heisenberg uncertainty principle, you don't know precisely where the electron is. Instead, it's smeared out between two atoms, which holds them together. Some of the mind-bending principles of the quantum theory are: you cannot know the exact velocity and location of any particle. There is always uncertainty. Particles can, in some sense, be in two different places at the same time. All particles exist as mixtures of different states simultaneously. For example, spinning particles can be mixtures of particles whose axes spin both up and down simultaneously. You can disappear and reappear somewhere else. All of these statements sound ridiculous. In fact, Einstein once said, "The more successful the quantum theory is, the sillier it looks." I want to use this moment to briefly inform you about Digital Butterfly. This channel is an independent project of a group of people with love for science and technology. Our research contains useful information from popular books and articles by well-known scientists and engineers. Our goal is to inform you about how the future is going to look like and give you an idea and familiarity with the technology and lifestyle we are going to face ourselves in the future. Naturally, when speaking about the future, not everything can be 100% correct, so always take everything with a pinch of salt. If you find these videos to be interesting and useful, do not hesitate to use your power to support the project by subscribing to our channel and liking our video. Next time, we're going to bring back the woolly mammoth, a brilliant beast that is long extinct, but perhaps with the advancement of technology, we'll be able to see them again. Tune in next time and we'll find out together.